Hi, my name is Sebastian Spinola. I'm a survey manager from Vision Survey, and we are here at Brighton train station to talk about a monitoring project. We've been asked by our client ML Consulting on behalf of Network Rail to undertake a ground movement monitoring at the cliff behind us. In partnership with Leica, and after a visit on site to see the conditions, we found that the best solution was using the new software and the new instruments, the MS50, due to the difficulties on site near the rail tracks and the cliff himself. We choose to do this monitoring with the laser scanning. With that instrument, we didn't need to go to the cliff to install prisms or to close the lines, what was made a lot of disruption for Network Rail. With the results of each one of these laser scannings, we were able to compare the readings to find any movements on a cliff on a clear and simple way for the client to understand.
Hello, my name's Graham Sharp and I'm the account manager for London, Kent, Surrey and Sussex for Leica Geosystems. We were delighted to be asked by Vision Survey to collaborate on this project. Leica Geosystems continues to innovate and bring to the market class-leading products, and with the new Nova system, Vision Surveys were able to see the benefits of this on this particular project. Using our Merge Tech technology, incorporating GNSS, TPS and laser scanning technology into one unit, the project here was able to see the benefits very quickly of this sort of equipment. On this unusual project, Vision Surveys were able to utilise all of the combined technologies within the Leica Nova system, enabling them to make the right decision. The complexities of this project meant that the use of conventional survey methods was going to be difficult. By utilising the Leica Nova MS50, Vision Survey were able to deliver not only the project in a fraction of the time that their competitors quoted, but also with a deliverable that far exceeded their clients' expectations.
My name is Jason Monk. I'm a Principal Geo-Environmental Engineer working for MLM Consulting Engineers. This project at Brighton Cliffs is part of the Earthworks monitoring contract for the South East region. We're working for B&M McHugh, who are in turn working for Network Rail. We are undertaking the geotechnical earthworks monitoring of 30 to 35 sites across the Wessex, Sussex, Anglia and Kent regions. The Sussex Geotechnical Asset Engineer at Network Rail asked MLM to have a look at a section of cliff in Brighton because the concrete surfacing to the cliff section was starting to peel away. The cliff section is 30 metres high and approximately 50 metres wide. The initial request from Network Rail was to install reflective targets on the concrete surface. This would have entailed using rope access, and we calculated approximately 360 reflective targets may be required, which would have been at a very high cost, and would have been included rope access and possible possession time as well. With the use of laser scanning, it provides a high degree of accuracy that you wouldn't get from reflected targets. The accuracy is down to 5 mil or 10 mil depending on the density of the grid that you require. In the areas of the cliff section where there was significant cracking and obviously areas of concern, we increased the density, and this would have been an issue with reflected targets. We wouldn't have been able to get that sort of accuracy, and the likelihood is that areas could have been missed. And this is the great thing about it. We can, from the 3D model, we can pinpoint where the areas of concern are, and then we can create a 2D profile and provide that to Network Rail and identify to them where the most amount of movement is occurring. This method could be adopted for much greater uses, not just on the earthworks monitoring that we've done here on this project. From a structural, civil and geotechnical point of view, its applications are far-reaching and I would recommend it.